Yo, what's up, Sci fan? It's your boy Nickel here, and we're going to look at what it takes to complete a scientific experiment. So that means we're going to title our page here at the top, Completing a Scientific Experiment. We'll define, what is an experiment and what are controlled variables. We'll define what the results are that we're looking for, and also how to write a conclusion in a specific format. So as you can see, we can fit all of this on one page. And you're just going to want to make sure that you organize it in this manner here. So like I said, our title of our page is going to be Completing a Scientific Experiment. All right, so when we first think about completing a scientific experiment, the first thing we need to do is we need to make sure that we're running our experiment. And this could be an experiment, or sometimes it could even be called an investigation. Actually, I'm going to put that in parentheses here because it's usually called an experiment, but some people do call it an investigation. And this is going to be the process that you use so that you can test your hypothesis. We want to know that based on what you already knew, was your guess correct or not? So you're going to test your hypothesis by running trials and collecting data. So as an example, in our paper airplane experiment, the goal is for us to test what type of paper is the best type of paper to make a paper airplane to go the furthest distance. So we're going to do multiple trials and we're going to collect data to see how far each type of paper airplane travels, so we know if our guess as to what type of paper is the best is correct or not. But something that's really, really important in an experiment is that we have some things that we call controlled. Think about what you do when you control something. So we call these controlled variables. And the controlled variables are the parts of the experiment. It's the parts of the experiment that remain the exact. I'm going to make this in all caps because it is so important. The parts of the experiment that remain the exact same for every trial. So for an example, if you did a different airplane design each trial, then we would be messing with too many variables. We would be not only changing the type of paper, but we'd also be changing the design. So a controlled variable is things that we don't change. It's the things that are the exact same for every trial. So in the paper airplane experiment, you're going to want to make sure that every single paper airplane that you fold is the exact same as the one that came before it. The first one and the second one should be exactly the same. And the third one and the first one should be the exact same, and so on and so forth. Every single paper airplane you make should be an exact version of the one before it in order to really prove that it's the paper. If we change the design of the paper airplane, then maybe it's not the paper, it could be the design. So it's really important we keep the variables the exact same when we do an experiment. There are certain variables that we don't want to change. Moving on is after the experiment, or while we're doing the experiment, we collect data and then we take a look at what did the results tell us? What is the data that we collected? What is it going to tell us? And we call that our results. So the results is when you analyze the data, the quantitative or qualitative data, you analyze it to see what patterns you notice. Like for example, is if you had a piece of cardboard and a piece of computer paper, maybe the cardboard here, the darker one, maybe that one does always, every time you throw it, the paper airplane doesn't go very far. But the computer paper one, perhaps every time you throw it, it goes further and further and further. Well, we're going to be measuring distance, and so we could use that quantitative data. We could look at the distance, and if we throw it multiple times with multiple trials, we could prove that the computer paper actually goes further than the cardboard does. The cardboard doesn't go as far. So that would be an example of the results. It's when you analyze the quantitative or qualitative data to see patterns. So one trial is not going to be enough. We want to look at the patterns. So multiple trials will allow you to see a pattern over time. Once you start to notice the patterns, then we can come up with our conclusion. And the conclusion is like the final part of an experiment. It's an explanation. It's an explanation of how the results relate to the hypothesis. an explanation of how the results relate to the hypothesis, because the hypothesis is what you guessed was going to happen. The results is what actually happened. And so in the conclusion, you say, well, guess what? This is what I was thinking, but then I collected all this information and all this data, and now this is what I know. So you go from what you think or what you expect to happen to what you know happens based on the results. So a conclusion is when you tell us about your hypothesis, whether it's incorrect or correct, based on the results that you accumulated over time. Now, it could also be described as a final statement. And it's a final statement to explain if the scientist should either accept or reject the hypothesis. So you can imagine if you guessed correctly, then you would probably say, well, we should accept the hypothesis. But if your guess was not accurate, then you would want to reject the hypothesis. So it's your final statement of saying, are you going to accept the hypothesis or are you going to reject the hypothesis? And the way that we know which one to choose is that we go back to our results, and our results are the data that we collected. So you must use data in your conclusions to explain if the hypothesis was accepted or rejected. Now, all of this is going to be based on the data, like I said. It's based on the data that was collected. The data that's collected is what we call our evidence. So whenever you write a conclusion, you must include a few things. Our conclusion format here is that you must start with your claim. And remember, the claim from our green circle portion of our unit is just that one sentence that is debatable. So this is going to be debatable. It should be something like saying that cardboard is not as good of a material to make a paper airplane compared to computer paper. That would be a claim. That's something someone could debate, but I'm going to state that. And in order to reinforce my claim and say, no, I am correct here, is I'm going to include E and R, which is evidence and reasoning. So I'm going to say my claim, and I'm going to say cardboard is not as good as computer paper. But here, I'm going to provide some evidence. And the evidence is super duper duper important because the evidence proves that your claim is either correct or incorrect. It supports your claim. And then the reasoning is how we talk about our evidence. So I want to give you an example of what this means. My claim: Colorado is the best place for high altitude training. Well, yeah, you could debate me on that, so that's a claim. That works out. I said it is the best place for high altitude training. Now let's take a look at my evidence and my reasoning. Here we go. Since Colorado has 54 peaks, there's some quantitative data. So it has 54 peaks that rise to a summit greater than 14,000 feet. So there's some more quantitative data, is that there are 54 peaks that are greater than 14,000 feet. So since Colorado has 54 peaks that rise to a summit greater than 14,000 feet, there are more opportunities for athletes to access high altitudes compared to other states. So in this example, let's use a couple colors here. Here is my evidence. Here's my quantitative data. But in order to have this evidence make sense, I have to use some reasoning. So my reasoning is what makes my data make sense. So my reasoning is everything around what I used for my evidence. So it'd be like saying that since Colorado has 54 of those peaks that rise to a summit that's greater than 14,000 feet, my reasoning is then that there are more opportunities for athletes to access high altitudes compared to other states. So in this example, you can see my reasoning is in orange, my evidence is in purple, and my claim is in yellow. And that's how we make a complete conclusion, is we use this format that's known as CER. You start with a claim, and then you provide evidence and reasoning to emphasize and to strengthen your claim. This will happen in every single science experiment, and we'll be experimenting with these CERs and practicing the CER framework as we write conclusions throughout the school year. That's all for now, and I'll catch you on the next video.